Hi all, welcome to the fifth lecture on computer organization and architecture. In the previous lecture, we have seen about instruction set architecture and the evolution of instruction set throughout the years. Today we'll be seeing about types of instructions and instruction format in detail. So moving on to the types of instruction, there are three basic types of instructions available. So the first one is data transfer instruction, the next one is data manipulation instruction, and the last one is program control instruction. We'll see one by one with an example. Data transfer instruction. So data transfer, as the name indicates, you're going to transfer a data from one location to other. Take first example. Here, load R1, X. So X is the location in memory. So it is a location, it is address of a location in main memory. We go to that location, we bring the data in the address X, and we load it to the register R1, which is present inside the processor. So that is what is going to happen here. The data from the memory location X in main memory will be loaded into the register R1. So we are loading a data from one memory location to the register R1. So this is a data transfer instruction. And move. If you come to the next example, it is move instruction. What is happening in this move instruction is you are moving the data from register R2 to R1. So data from the register R2 is moved to the R1. So apart from load and move, there are many more instructions available under data transfer instruction. Example, store, exchange, and so on. So this is all about the data transfer instruction. Next, moving on to the data manipulation instruction. Data manipulation instruction, it is used to manipulate, it is used to perform arithmetic and logical operation on the data available. Example, add immediate, subtract, multiply, divide, and etc. Let us see in detail about each and every instruction. Add. So what is this instruction doing? It is going to add the data in the register R1 and the register R2, and it will place the result in the R2. So R1 is equal to R1 plus R2. So the final result will be placed in the R1. Okay, so this is what will happen for the first instruction. The next example is this. If you see add immediate, immediate is that you are directly specifying the value to be added in the instruction itself. So 50 is the value that is to be added with the register content and R1 resistance content. So what will be actual manipulation performed here is R1 is equal to R1 plus 50. So this is what will happen in case of this second instruction. Okay, so this is a data manipulation instruction. All the arithmetic and logical instruction, shift instruction, and logical or not, and everything will be coming under this data manipulation instruction. And moving on to the third type of instruction, it is program control instruction. Program control, which by the name suggests, you are going to move the control to some other location in memory. Suppose, example for this program control instruction is branch jump. So depending on a condition, if an instruction has to go to the next instruction, or an instruction should jump to some other location in memory, say 3000 or 5000. So moving, if the instruction has to move on with the next instruction directly, or it has to go to the address 3000 or 5000, whatever mentioned inside this, is depending upon the condition that is given in the previous instruction. So control is transferred depending upon the current instruction that is being executed. So current instruction will direct which is the next instruction to be executed, the next instruction that has to be brought into the instruction register for execution. Okay, so that's why it is called as program control instruction. So depending upon this instruction only, you will have to branch to the next instruction, or you will have to branch to the address specified here. So example for program control instruction is branch and jump. So these are the three basic types of instructions available. Now we'll move on to the instruction format. As we all know, instruction consists of two major parts. One is opcode, the other one is operand. By operand, we mean that operand is not just depending upon the our instruction type. We have seen in the previous lecture, the number of operand can vary. It can have 0 operand, which means it is a 0 address instruction. It can have 1 operand, which means it is 1 address instruction, 2 operand, 2 address instruction, 3 operand, 3 address instruction. Similarly, depending upon the operand, your instruction formats vary. So operand can be source operand. There should be a source operand and a destination operand. Source operand can be, see, if you in the example, if you see, source operand can be of 3 options. Like a source operand can be data in the memory, or a source operand can be a data in the register itself, or a source operand can be an immediate value which is present in the instruction itself. So there are 3 possibilities in case of source operand, and there are 2 possibilities in case of the destination operand. One is directly you are storing the data in the memory, or your destination can be a register itself. So like we said, the operand can be a source operand or a destination operand. If it is a source operand, there are 3 possibilities. One can be a memory location in the memory, main memory. Second, it can be a register itself. Third, it is an immediate value which is specified in the instruction. For a destination operand, there are 2 options available. One, it can be a memory location in main memory, or it can be a register. So this is all about the instruction format. So let us see example based on the different instruction, what are all the instruction formats available. Okay, now if you see the first example, there is only opcode available. Example instruction is no operation or halt. You are going to end the program. So final step will be your halt, or no operation is do nothing operation that you have to put in the middle of your program. So in this case, you are not going to perform any operation at all. So only the opcode that has to specify these instructions is required. Nothing else is required in the instruction. So this is one kind of instruction format. Then there is only one operand, and the operand is a memory location. It is a location in memory, main memory. Okay. In that case, what will be the format? You need to specify the operand of what instruction to be done, and the memory address, which is location in memory, main memory, that is from where the data has to be picked. So this is the format for these instructions. And moving on, we have 2 address instruction. 2 address instruction, both are memory addresses. Both are at location in main memory, X and Y. So in that case, this is how your instruction will look. Opcode, memory address, and memory address. So this is how your instruction will look. In there is a second case in 2 address instruction, wherein one of your operand will be a register, the other operand will be your memory location and memory. Okay. So now in that case, this is how your instruction format will be. Your opcode, obviously it will be there. There will be a register memory location, and the memory address, wherein you have to specify the memory address. So this is the second type of 2 address instruction format. The third type is, and the last example is 3 address format, wherein all 3 are registers. So here 2 sources are available and 1 destination is available. So you have to specify the source register address, destination register address inside the instruction format itself. Okay, so these are the examples instruction formats available for each and every instruction, kinds of instructions placed. Okay, now we'll take an example and see how the instruction format is designed. Okay, I'll draw this. Okay, consider a 32-bit fixed size instruction. So we are going to deal with the fixed size instruction because that will be a comfortable one for understanding. Fixed size instruction, and it is of 32-bit. So now we are going to design a instruction format which is of size 32-bit for this instruction. This is a sample instruction we have taken, and we are going to design instruction format for this instruction. If you see, this is a 2 address instruction. One of the addresses register, the other one is the memory location in memory, and there is one more information given. It is 32-bit general purpose register. So there are total number of 32 general purpose registers available. So 32 general purpose register in the sense R0, R1 to R31 is available. So how many number of bits is required to represent each and every register is 32, can be written as 2 raised to the power of 5. So total number of 5 bits is required to represent each and every register. So the first register R0 can be represented by 5 bit 000, R1 can be represented as 0001, R2 can be represented as 00010, and so on. Finally R31 will be 1111. So 5 bit is required to represent the register itself. Okay, so we are going to divide the instruction format like this. The first part will be opcode. Okay, and the second part, this we are going to divide and write. What is this instruction actually? R1 is equal to R1 plus memory A. Okay, so we are going to bring the data from the memory location A, add it with R1 and place it in R1. So this is your destination register, this is your source register, this is your source, and this is also your source. So 3 address can be mentioned. One is for destination register destination has to be mentioned. Other is also a register source and the memory location. So this is a memory address. Okay, register destination, register source, and the memory address is needed here. Okay, now so as we know, register destination, we require 5 bit to represent this register destination. Similarly here it also requires 5 bit. Now we are going to assume that memory address required is 20 bits. So this is an example that I am explaining you. We are taking memory address as 20-bit memory address. We need 20 bits for memory address. So total, if you see how many bits are available, 20 plus 5 plus 30. So the remaining bit available for opcode is 2 bit. Okay, there are 2 bit opcode, which means 2 bit, on 2 bit how many possibilities are there in the opcode? This is 00, 01, 10 and 11. So there are only 4 possibilities in the opcode which may represent, say, this is an add, this is for subtract, this is for multiply, this is for divide, something like this. So only 4 operations are possible. This is not any specific architecture that I am explaining, this is just an example. So we are taking, there are total 32 general purpose register available. So number of bits required to represent register is 5 bit each. So there are 2 registers required, 5 bit each, and we are assuming that memory address needs 20 bits to represent. So the remaining is given for opcode. Opcode is 2 bit. 2 bit, how many possibilities are there? There are 5 possibilities, and there are only 5 operations used to represent with this 2 bit opcode. So this is all we have written. This is an instruction format we have written for this instruction. We'll take one more example and see. We'll take one more example and see what can be written. So this is, I'll run this again. Load R11, 100 R2. Okay, so this is one kind of instruction where you have an immediate value here. Immediate value is nothing but you have a direct number specified in the instruction, and you have 2 registers available. So again, we'll take the same prerequisites. There are 32, the instruction is 32-bit fixed size instruction, and there are 32 general purpose registers available. Now let us frame the format for this instruction. So total size of this instruction will be 32-bit. Okay, so as 32 general purpose registers are available, so the number of bits required to represent each register is 5 bits. So now what is happening here is R11. So what will happen here is memory R2 will be first added with this 100 and the value will be taken from memory. R2 plus 100's locations value will be taken and it will be loaded to the register R11. So this is what is operation that is mentioned here. Okay, so now there are 2 register value and 1 immediate value present. So apart from opcode, there are 3 partitions required. 2 for register and 1 for immediate. So this is for register destination, which is R11. This is for register source, which is R2, and this is for 16-bit. Imagine this is also, there is a 16-bit immediate value. Okay, immediate value which is 100. Okay, so now these are the 3 requirement for the operand part. So we have mentioned here. So when my destination is R11, so 11 can be mentioned like this: 1011. So 1011 is 11, right? 8421. No, sorry, 1011. What is the required? 8, 9, 10, 11. Yes, 1011 is for 11. Okay, so 1011 is the destination. What is your R2? R2 will be 0010 is your R2. 16-bit immediate is 100. You have to represent 100 in binary numbers. And total number of opcode bit, this is 16 bits. Okay, so this is 5 bit, this is 5 bit. 5 plus 5, 10 plus 16 is equal to 26. 32 minus 26 is 6 bit. So total number of bits given for the opcode is 6 bits. So how many number of operations is possible is 2 power 6 operations are possible, which is 64 operations are possible in this example. Okay, so this is how you design an instruction for. This is how an instruction format is made. So 3 operands are mentioned as 3 parts here. One is register destination, register source, and immediate value. So this is all about the instruction format. We'll see about addressing modes, how these locations, how these addresses, how these register values can be picked from an instruction is through the addressing mode. Addressing mode we'll see in the next class. Hope you understood about what are the types of instruction and what are the instruction format available. Thank you for watching this video.